Hi, my name's Ron Cole. I'm a small businessman, retired from Ukiah, California. Like most people, I'd like to do my part in helping protect our environment for future generations. We all like the comfort and convenience of heating and air conditioning, but the problem is this. They all operate by burning fossil fuel. Even nuclear power requires fossil fuel to produce the plants and to prevent them from melting down in the case of an accident. Either way, it's not good for us and it's not good for the planet. So I'd like you to take a critical look at a possible alternative. This device weighs about 2 pounds. It's made of copper, carbon, and plastic, and it can be assembled by anyone accustomed to using hand tools. In simple terms, it works by using a new form of magnetic induction. This unit is UL certified to output about 1,000 watts. These units are being built locally in the form of a kit, which I'll demonstrate here. 3 different coils of nano-coated copper are put together, assembled, and slipped into 3 stacks. And once that's done, the 3 are joined together and connected to an AC cord and then connected to the grid. By using grid electricity to trigger this unit, additional power is added from the local environment to supply individual homes. Since it always has grid backup, reliability is assured, regardless of weather or time of day. In fact, it's very much like a solar power installation with a grid intertie. Let's take a look at how it actually operates when it's plugged into the grid. The watt meter on the left shows power being drawn from the grid. The watt meter on the right shows the combined power of the grid plus the power unit. This unit is regulated by demand. So right now we're not demanding much, and so the quiescent power being drawn is about 6.7 watts that we're taking from the grid, and we're obviously losing some in the circuitry. So now we're going to show what happens when we increase the load by plugging in a small load consisting of this window fan. So now the grid load has increased to 34 watts. The power being supplied to the fan is about 65 watts. This is a total of the grid at 34 and the remainder being supplied by the Magrav unit. What we're going to do now is increase the load further, and you'll see that the more you ask from the Magrav unit, the more power you get. So we're going to plug in a radiant heater. It'll pull about 400 more watts. So now the grid watts we're pulling, and these are the watts that I have to pay the power company for, is about 287 watts. Meanwhile, the total load of the fan and the heater are pulling 462 watts. In personal terms, this cuts my power bill in half. At the national level, that's the equivalent of cutting the number of power plants in half. You might be wondering how much one of these units cost. A kit form like we're building here costs $320. A pre-assembled unit, it costs about $500. It does, however, require a 3-month lead time. These units are made in the US and could be made anywhere, including Willits.